Okay, the proof. PF standing for proof. What do I want to do? So let's start talk. So what is the feature of a convergent sequence? Okay, by definition, it means that Sn is convergent. So what is Sn? Sn is going to be A plus AR squared plus dot 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 plus so what do we get? The last term is going to be let me just think it's this one, right? AR n minus 1. And yeah, because we have n equals, that's how many terms we have there. We want to have a total of n terms. So this is the n term, n equals 1, n equals 2, n equals 4, n minus 1, and then n. Okay. Now, a little trick here, which we're going to use, is to, well, what I want to do is I want to find, what do I want? I want lim Sn, which equals, summation that I'm looking for, right? So I'm going to do a funny trick. I'm going to multiply both sides by r. And what do I get? Well, the a term gets multiplied by r and ends up here. And then you get plus AR squared plus all the way up to AR n minus 2 plus AR n minus 1 plus one extra term on the end, AR n. Now I'm going to look at these two lines and say, well, look what happens when I subtract them. Okay, this proof is very, it's got a real technique to it. So don't worry if this seems a bit, don't worry if you say to yourself, oh, that's all fine and good, but I would never come up with that myself. Okay, don't worry about that. It's math is like that. So I subtract these two lines. So I take, it's like when you're subtracting equations when you want to eliminate a variable. So I do a subtraction of these two lines. And what happens is you get these cancellations, right? Cancel, 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 cancel. The only survivors are this guy and this guy. Now, what's the point of this is that on the left-hand side, I can factor out Sn, and I get 1 minus r is equal to a minus a. Ba, 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 ba. So Sn is equal to a minus a r n over 1 minus r. Now we recall, because we want to do the limit of this, right? We want to do the limit of Sn, Rn goes to 0 if, r is less than 1. So if, r is less than 1 in absolute value, lim Sn, come on, Sn is equal to a minus 0 over 1 minus r, which is a over 1 minus r. So summation a r n minus 1 is equal to A over 1 minus r. Okay, so what about the other cases? If r is equal to 1, the sum is, well, none of this works over here, right? You can't divide by 1 minus r here, right? Okay, more specifically, you have a sum a, which is going to be a plus a plus a. Which is divergent unless a is equal to 0. Okay, if you add up a non-zero number, sorry, an infinity of a's, it's not going to converge. Okay, I'm using some logic there, which I'll make more precise later on. But hopefully you agree that hopefully you agree that if I add up an infinity of a's that are not 0, then it's going to diverge. And if r is equal to minus 1, sum is summation a negative 1 to the n minus 1. And I pretty much covered this when I did negative 1 to the n. Okay, you have this alternating series. And we can show that the sequence of partial sums does not converge. So here's my formula. The sum of a geometric series so you should memorize this formula. We'll be using it plenty often.